66 million years ago, the most perfectly engineered killing machine to ever walk the Earth was wiped out in about 72 hours by an asteroid the size of a city. It didn't lose a fight. It didn't fail as a species. It got unlucky. So here's the uncomfortable question. What happens if that same animal shows up today? Not in a movie, not in a theme park, actually biologically in the real Montana wilderness right now. How long does it survive? How long before we have a problem? The answer is genuinely surprising and a little bit terrifying. Day 1. It hatches on a Thursday, which is already an inauspicious start. The egg is the size of a watermelon, buried in a shallow depression in the sun-baked dirt of the Hell Creek Badlands. The same geological formation where most T-Rex fossils have actually been found, which is either poetic or deeply ironic, depending on your perspective. The hatchling is about 3 feet long and weighs roughly 11 pounds. It looks, to be completely honest, like a very aggressive chicken. This is not a knock on the T-Rex. This is just what apex predators look like before they grow into their reputation. Its first problem is immediately apparent. The Cretaceous Hell Creek ecosystem it was built for had ferns, cycads, flowering plants, and roughly 40 species of dinosaur sharing the same patch of ground. The modern Hell Creek formation has sagebrush, rattlesnakes, and a decommissioned ranch about 4 miles east. The prey it was genetically programmed to hunt, hadrosaurs, ceratopsians, juvenile sauropods, no longer roam these lands. Its survival hinges on adapting or perishing. For the first few months, it eats lizards, small mammals, and whatever it can ambush near water sources. This is survivable, but not sustainable, because a T-Rex's metabolism is calibrated for large prey, and running on mice is like trying to fuel a freight train with birthday candles. It works technically. It is not a good long-term strategy. What nobody would expect, including most paleontologists, is how fast it learns. Part 2, the intelligence question nobody was asking. Here is something the pop culture version of T-Rex gets completely wrong. For most of the 20th century, the T-Rex was portrayed as a giant, slow, reactive animal that relied purely on size and power. A biological bulldozer. Recent science has significantly complicated this picture. Brain-to-body ratio analysis, inner ear structure studies, and comparative neurology with modern birds, which are literally living dinosaurs, suggest that T-Rex had processing capabilities somewhere between a crocodile and a crow, which is to say, not a genius, but absolutely not the dim-witted muscle it's been caricatured as. It has binocular vision better than a hawk's, a sense of smell that rivals a bloodhound, hearing calibrated for low-frequency sound that travels long distances through terrain, and a memory that, based on what we understand about similar animals, is capable of associating locations with food, danger, and past experience. So when a game trail near a river bend keeps producing deer, it remembers. When a particular ridge produces wind direction that carries its scent to prey, it learns to approach from the other side. When a rancher's floodlight clicks on every night at the same time, it notes the pattern and hunts on the opposite side of the valley. It is not outsmarting anyone, but it is adapting faster than the news cycle can keep up with. Part 3. The food problem, quantified. By year 2, it's 12 feet long and pushing 400 pounds. This is where the survival math starts getting interesting in uncomfortable ways. A fully grown T-Rex needs somewhere between 100 and 250 pounds of meat per week, depending on activity level, ambient temperature, and growth phase. This is a lot. This is an elk every 10 days, or a bison every 2 weeks, or a truly embarrassing number of deer, if that's what the week offers. The good news is that North America still has large prey: elk, bison, moose, mule deer, pronghorn. The continent isn't empty. The bad news is that every single one of these animals has been hunted by wolves, bears, cougars, and humans for thousands of generations. They are, evolutionarily speaking, extremely paranoid. Hadrosaurs in the Cretaceous had never encountered a predator with binocular vision and a 5-foot skull. Modern elk have been running from apex predators since before recorded history. The prey is faster, more evasive, and more socially coordinated than anything the T-Rex's ancestors ever encountered. Its success rate in year one, roughly 35%, which means for every 3 hunts, it fails twice, burns energy it can't afford to burn, and has to try again sooner than it should have to. By year 3, that number climbs to 58%, which is the adaptation piece. It is genuinely getting better at hunting animals that weren't supposed to exist when it was designed. On day 847, it kills a black bear that wandered into its path near a creek bed. The bear weighed 340 pounds. The encounter lasted less than 4 seconds. This was not a calculated hunt. It was an opportunistic ambush, but the outcome is unambiguous. A game warden finds the carcass 2 days later. The bite radius doesn't match any North American predator, living or recently extinct. A forensic zoologist is flown in from a university in Colorado. The investigation begins before the T-Rex has even finished digesting. Part 4. The part where humans make everything more complicated. The federal government identifies the animal in month 19. This sets off a chain of institutional chaos that is genuinely more complex than the ecology of the situation. The Fish and Wildlife Service is asked whether a de-extinct Cretaceous theropod qualifies for protection under the Endangered Species Act. Their legal team produces a 47-page memo that essentially concludes, maybe, but it depends on definitions of species and native habitat that the original legislation definitely did not anticipate. The memo uses the phrase unprecedented taxonomic ambiguity 4 times. The Department of Defense is quietly briefed, which it finds simultaneously alarming and fascinating. 3 universities submit emergency grant applications to study it. 2 different biotech companies immediately begin arguing over intellectual property related to any genetic samples that might be collected. A legal position that a federal judge will later describe as creative. And somewhere in Texas, a man offers $40 million for a hunting permit. Meanwhile, the animal is just trying to eat enough to get through the week. The helicopters start in month 22. Aerial monitoring, GPS tracking of kill sites, thermal imaging surveys. The T-Rex doesn't know what a helicopter is, but it knows that a loud, chemical-smelling thing appears over every large carcass within 48 hours of a kill. So it starts moving immediately after eating. This burns more calories, which means it needs to hunt more, which produces more carcasses, which produces more helicopters, which means more moving. The feedback loop is not going well for anyone. In March of its 4th year, it kills 14 cattle on a ranch in Garfield County, Montana. The government asks that this not be reported to the press, which results in it being immediately reported to the press. Year 12, 40 feet long, 9 tons. The largest land predator currently alive, by a margin so large that the second place isn't even worth mentioning. At this size, the ecological reality becomes stark. There is nothing in North America that can challenge it in a direct confrontation. Grizzlies avoid its range entirely. Wolf packs reroute. Mountain lions disappear from trail cameras in a 200-mile radius around its known territory. The cascade effect on secondary predators is measurable and documented in 3 separate peer-reviewed papers. But here is the catch, and this is the part that would have surprised most people who asked the original question, expecting a simple yes or no. It is not thriving. It is surviving, which is a meaningfully different thing. The bison herds that once covered the Great Plains in the tens of millions are now fragmented populations, managed across reserves too enormous. It covers ground that would have fed 3 or 4 individuals in the Cretaceous, and it is doing so alone, because there is no population, no species, to sustain anything beyond this single animal. The ecosystem is also quietly rebuilding around its presence in ways nobody fully predicted. Elk herds in its core range have shifted their migration timing. Bison have altered their grazing patterns. Even bird populations near its regular kill sites have reorganized, with some scavenger species following its movements, the way they'd follow a wolf pack. It has become, in the strictest ecological sense, a keystone predator in a system that didn't have one of its particular type, and the system is adapting to it rather than the other way around. This is remarkable. This is also not enough. Conclusion: the real Rex survive in the modern world? Yes. Physically, metabolically, behaviorally, yes. But the question underneath the question is whether an animal that defined an entire geological era can find a home in a world that built itself completely from scratch in its absence, and that answer is more complicated. The modern world didn't leave room for it. Not because the world is hostile, it's not particularly, but because 66 million years of evolution filled every gap it left behind. Every niche it once occupied has been subdivided, specialized, optimized by animals that showed up after it was gone. The prey got faster. The ecosystems got more complex. The top of the food chain, when the T-Rex was alive, was a single large slot. Now it's a layered web of competing pressures, and dropping a 9-ton Cretaceous predator into the middle of it doesn't restore something the web doesn't know how to process. It survives. It hunts. It reshapes behavior in every animal within 200 miles just by existing. And somewhere in a federal building, a task force meets every 2 weeks to argue about what to do about an animal that is simultaneously the most endangered species on Earth and the apex predator of a 4-state region. The asteroid ended the T-Rex fast. The modern world keeps it alive, just barely, while slowly running out of places to put it. If you enjoyed this video, don't forget to like, comment, and subscribe for more content. See you on the next.